Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little's Law YouTube channel. So today in this video, we're going to talk about the task organization, the task sets, the sequential task, and the nested structure. And this is going to be a transformational video for you on how you write the locus test. So we're going to move beyond simple task to build complex, realistic user journeys. And up until now, you have been using the at task decorator, right? So your tasks run randomly, and that's fine for some scenarios. But what about when you need order? What about when users must follow specific steps? And today you will learn three powerful patterns, which is the sequential tasks for ordered execution, task sets for grouping related behaviors, and nested structures for complex scenarios. By the end of this episode, you'll be able to model any user behavior pattern, no matter how complex. So let's dive in. So the problem with the simple task is, let me start by showing you the problem. So here's the issue with the basic at task decorators. They run randomly. There is no guaranteed order. And imagine testing an e-commerce checkout. Your test might try to pay before adding items to cart, and it might try to check out before even browsing products, and that's not how the real users behave, right? So real users follow a logical flow. Yes. The second problem is you can't model complex user journeys. What if you want to test a complete workflow? Login, browse products, add to cart, enter shipping, make payment, view confirmation. That's 6 steps, and that must happen in order. So the basic at task decorators cannot guarantee this sequence. And then the third problem, it is hard to organize related tasks. So as your tests grow, you might have 20, 30, 40 different tasks, and some are related to browsing, some to checkout, some to account management, and they are all mixed together in one class. It becomes a mess. So we need structure. Yes, we need structure. We need ways to organize, sequence, and group our tasks. And that's exactly what we are learning today. The third way, the third one, the three solutions. So here are three solutions, and think of these as tools in your toolbox, and each one solves different problems. The first one, the task decorators with weights. This is what you already know, the at task decorator with optional weights. Tasks execute randomly based on their weights. Use this when the actions are independent and order does not matter, like testing different API endpoints that don't depend on each other. And next comes the second box, the solution to the sequential task set. And this is new. The tasks execute in the exact order you define them, top to bottom, step by step. Use this when you need guaranteed order, login flows, multi-step forms, checkout processes. Thirdly, the task sets for grouping. So this lets you group related tasks together. You can have multiple task set, and Locust will switch between them. Use this when you have different types of users or different behavior patterns, like browsers versus buyers or admin users versus regular users. These three patterns can also be combined. That's where the real power comes in. We'll see that later, but now let me show you each one in detail. So now the sequence, the slide 4, the task decorators review. So let's quickly review task decorators since you already know these. Here is a typical code, 3 tasks with different weights. So at tasks of 5 means weight 5, right? And at tasks 2 means weight 2. So no number defaults to weight 1, right? And then the next one, the tasks run randomly based on weight. Yes, the weights determine probability, not the order. So if you have weights 5, 2, and 1, that's a total of weight. So browse products runs 5 out of 8 times, add to cart runs 2 out of 8 times, and checkout runs 1 out of 8 times. But the order is random. So you might see browse, browse, checkout, add cart, browse, checkout. The third one, this is perfect when the actions are independent. So testing a REST API with multiple endpoints, great use case. Testing different pages that don't depend on each other, which is perfect. And then But this is terrible for workflows that need order. So you cannot guarantee checkout happens after adding to cart. You cannot ensure the login happens before accessing protected pages, and that's the limitation, and that's why we need the next pattern. So the slide 5. Yes, so now here's the game changer, the sequential task set. Yes, look at this code carefully and you can notice the differences. First, we import sequential task set instead of the regular task set. Second, our class inherits from sequential task set. Third, there are no weights, no numbers in the at task decorators, just plain task. And next comes the magic. So this runs in order, right? So step 1, then step 2, then step 3, then step 4. Then it repeats step 1, step 2, step 3, step 4 over and over in the same order, right? So top to bottom always. This is exactly what you need for workflows. Think about it. The user registration, you enter email, then the password, then confirm password and submit. And next comes the e-commerce checkout. So add to cart, enter shipping, enter payment, confirm, and then the login process, username, password, two-factor code, and access granted. All of these require order. Sequential task set gives you that. So the tasks execute top to bottom in the order they are defined in your code. Simple, predictable, powerful. And this is probably the most important pattern you will learn today. So most real world user journeys need sequential execution at some point. And next, the slide 6. So let me clarify the difference between task set and sequential task set because this confuses people. So the regular task set, random execution, tasks run in random order based on weights. Weighted tasks, you can use at task of 5, at task of 3 to control the probability. The group related tasks, which are great for organizing code, no guaranteed order, you never know which task runs next. So use task set when you want to group tasks but don't care about order. And next is the sequential task set. So ordered execution, always top to bottom, which is perfect for workflows. Login, then browse, then checkout. Step-by-step user journeys. Each step depends on the previous one. No randomness, completely predictable. Use sequential task set when order matters. And now think of this way. Task set is equal to organized chaos, related tasks grouped together but still random within the group. Sequential task set, which is march in line. Every task knows its place and waits for its return, for its turn. Both are useful. You'll use both depending on what you are testing. And next comes the slide 7, the nested task sets. So now let's go advanced. So this is nested task test sets, the task sets inside the task sets. Yes. So look at the structure carefully. So at the top, we have browse products, a regular task set, random browsing behavior. In the middle, we have checkout, a sequential task set, ordered checkout steps. At the bottom, we have e-commerce user, the main user class. It uses both. And next, this is the power of nesting. You can mix patterns. Users might browse randomly, but when they start checkout, it must be sequential. Or you might have random browsing, sequential login, random product viewing, sequential checkout, random post purchase behavior, and each part uses the right pattern for that behavior. So the e-commerce user has a task list containing both task set. Locust picks one randomly, executes it, then picks another. So a user might browse, start checkout, sequential steps, browse, start checkout again. So this model, realistic behavior. So the real users browse randomly, but when they decide to buy, they follow a specific sequence. And this is professional grade load testing. So real applications are complex. Nested task sets lets you model that complexity accurately. And then the eighth slide, when to use what to say. So the decision time. So when should you use each pattern? Let me give you clear guidelines. So use basic at task decorators when you have independent actions with no order needed. The perfect examples are testing different API endpoints that don't depend on each other, random page views on a website, different search queries, independent CRUD operations. If there is no dependency between actions, use at task. Use sequential task set when you need step-by-step workflows. And the perfect examples are login process, username, password, two-factor, the checkout flows, cart, shipping, payment confirmation, the multi-step form, step 1, step 2, step 3, submit, the user registration details, verification, and confirmation. So anytime one step must follow another, use sequential task set. And next, use nested task set for complex applications with multiple user types. So the perfect example are e-commerce, browsing, random browsing plus checkout sequential, social media, feed scrolling plus post creation sequential, banking app, account viewing plus money transfer sequential. So admin versus regular users with different behaviors. So when your app is complex and has both random and ordered behaviors, nest your task sets. So here's a simple rule. Start simple, use add task. When you realize you need order, switch to sequential task set. When your tests get complex, start nesting. Don't over engineer. So use the simplest pattern that models your user behave correctly. And then the real e-commerce example. So let me give you a real example that ties this all together. An e-commerce site with a realistic user behavior. So 70% of your users are browsers. They are window shopping. They view the homepage, look at categories, maybe search for products, but they don't buy anything. They are just looking. So for these users, you would use a regular task set with random browsing tasks. No order needed. They are clicking randomly. And then 20% go a step further. They browse and add items to cart, but they don't complete the purchase. Maybe they are price comparing. Maybe they are saving items for later. These users need two task sets, one for browsing, one for cart actions. And then only 10% actually complete a purchase. These users need the full treatment, browsing plus complete checkout. So the checkout must be sequential, add to cart, enter shipping, enter payment, confirm order. It can't happen out of order. And then this is realistic. So in real e-commerce, most people browse, fewer add to cart, even fewer complete purchase. So your load test should match this distribution. 70 browsing users, 20 cart users, 10 checkout users. So you can control this with weighted task set in your HTTP user class. This accurately represents your actual user base and gives you meaningful performance for each user type. This is the difference between amateur load testing and professional load testing. Professionals model real behavior, not just generate random traffic. So finally, the last slide. So the number one, task decorators with at task give you random weighted execution, simple, flexible, perfect for independent actions. This is your default choice for basic load testing. Number two, sequential task set gives you ordered step-by-step execution. Tasks are run top to bottom, always in the same order, perfect for workflows that require sequence. And then number three, tasks that let you group related tasks together. They organize your code, create reusable behavior patterns, separate different user types, keeps your tests clean and maintainable. And then the nesting. The nesting task sets handles complex realistic scenarios, makes random and sequential behaviors, models sophisticated user journeys. This is professional grade load testing. And then the banner of ready to code. Yes, you now have the knowledge, you understand the patterns and when to use one. Next step, code. We are going to implement all four patterns with working examples. You will see the pattern in action, watch them run and get the complete code to use in your own project. And this is where it gets fun. You are about to see your user behavior come to life in your load test. With that, I come to the end of this video. So until I see you all in the next videos, bye bye from Ashish Shanmugam and your favorite Little Slaw YouTube channel. Take care and bye bye.